Okay, let's just think about this for a second. When you picture a building, you probably think of something that just consumes energy, a whole lot of it, right? But what if we could completely flip that idea on its head? What if our homes, our offices, could be more than just shelters? What if they could actually be their own resilient, self-sufficient power plants? We're going to explore how that's not some far-off dream. It's already happening.
And it all starts with this really powerful idea. This isn't just about saving some money on your electric bill. Not at all. It's about building things that are just fundamentally tougher, more resilient. You know, as Dan, the owner of this amazing house we're about to look at, says, these buildings are just better prepared for whatever the future throws at us.
So what on earth is this number? -9. Well, that's the house's official energy rating. It's her score. To give you some context, a brand new standard home scores about 100. If you get a score of 0, that's a huge deal. It means your house makes as much energy as it uses. But -9? That means this house doesn't just break even. It's a net energy producer. It's actually putting more power back into the grid than it takes out.
And that negative score? Well, it translates into some seriously positive cash. We're talking an estimated $300,000 in savings over the next 3 decades. And get this, it wasn't some crazy expensive moonshot project. It only cost about 10% more upfront than a typical house. So how is that even possible?
Well, it all comes down to a set of principles called passive house design. And it's not about a bunch of complicated gadgets. Nope, it's about a brilliantly simple, totally performance-based way of building. So, let's open up the playbook. The core strategy is honestly so smart and simple. First, you wrap the entire house in a super thick, continuous layer of insulation. Think of it like a big, puffy jacket. Then you make the whole thing incredibly airtight, sealed up like a submarine, so no energy can leak out. Third, you get strategic with your windows, treating them like a currency. And finally, you use a smart ventilation system to bring in fresh air without wasting all that energy you've worked so hard to keep inside. This really says it all, doesn't it? The builders say a typical home is basically Swiss cheese. It's just full of all these tiny little holes and cracks that are constantly leaking out your expensive heating and air conditioning. But a passive house, it's sealed. And that creates this incredibly stable, quiet, and super comfortable environment that hardly needs any heating or cooling at all. Let's dig into this window currency idea, because it's genius. In a passive house, every single window is a calculated move. You spend your window budget on the south side of the house, where you can soak up all that free heat from the sun in the winter. But on the north side, where there's no sun to gain, you save that currency, because any window you put there is just a place where you're going to lose heat. It's just smart. It's just physics.
So what's the payoff for following this playbook? Well, here it is. 90%. That's the reduction in energy you need for heating and cooling compared to a normal house. That's not a small tweak, folks. That is a complete game changer.
Okay, saving energy is one thing. That's amazing. But what if we take it to the next level? Let's talk about how buildings can actually become power plants themselves. And that's where this incredible technology called Building Integrated Photovoltaics, or BIPV, comes into play.
So forget what you think about solar panels. You know, those big, clunky things bolted onto a roof. BIPV are the building materials themselves. We're talking about roof tiles that generate electricity, windows that make power, the glass on the side of a skyscraper. All of it is quietly generating clean energy. The building's own skin becomes the solar panel. And you can see just how versatile this tech is right here. Over on the left, that's the Bullitt Center in Seattle. It uses its giant roof as a massive solar array that powers the entire building and then some. And on the right, look at the Packard Foundation in California. Those aren't just decorative panels on the walls. They're generating electricity while also providing much-needed shade. 2 birds, 1 stone. And the possibilities are just mind-blowing. We're talking about solar shingles that look exactly like regular ones, windows that are semi-transparent so they let in light and make power, entire wall systems, even flexible solar laminates you can put on curved surfaces. It's all about making energy production a totally invisible, seamless part of the building.
So, we've seen this works for a house, but can you really take these ideas, radical efficiency, integrated power, and scale them up to a skyscraper? Well, the answer is a huge, resounding yes. Let's look at some big-time commercial buildings that are already doing it.
Check this out. This is the Energy X DY building in South Korea. It's a 7-story commercial building, and it uses that exact same passive house playbook we just talked about and then combines it with a massive solar facade. The result? They call it a small power plant because it's officially a plus energy building.
Yeah, 129%. That's its energy self-sufficiency rate. This building doesn't just cover its own energy needs, it produces almost a 30% surplus that it can sell back to the grid. It's not net zero, it's net positive.
And then there's this absolute legend, the Bullitt Center in Seattle, which we saw earlier. This building was literally designed to be a living example of what is possible, and it's earned the nickname the greenest building in the world.
This chart puts it all into perspective. Just think of that EUI number like a building's miles per gallon rating. A typical office in Seattle has an EUI of about 67. The Bullitt Center, just over 10. That's nearly an 85% improvement in efficiency, and that's before you even count all the power it generates itself.
So all these examples, from Dan's house to this huge office building, they're all aiming for the same goal, to become a net zero energy building. It's the perfect combination of everything we've been talking about. First, you get super smart with the design to slash the amount of energy you need. Then, you use on-site renewables, like BIBP, to generate that small remaining amount yourself.
Okay, so you might be thinking what I'm thinking. If this technology is so incredible, why isn't every single new building a net zero building? And that's a fair question. The reality is, there are still some pretty big hurdles we need to get over.
And these challenges are real. First off, there's the higher upfront cost, which can scare people off, even though you save a ton of money in the long run. Then you've got policy issues and a real shortage of architects and builders who know how to do this stuff. And maybe the biggest hurdle of all is just that most people don't even know this is possible.
But here's the thing. All of those are solvable problems, which leaves us with one last really big question. In the US, our buildings are responsible for a jaw-dropping 41% of all energy we use. We have the technology, right now, to turn our biggest energy hogs into a giant distributed network of clean power plants. So the real question is, what are we waiting for?